2,400 per minute. Okay, so every 3 seconds we fire once. Sorry, the rate of firing is 2,400 per minute. Okay, and every time we fire is 3 seconds. And we ask this: what is the probability of exactly 50 hits? 50 hits. So in this case, let's check the problem again. We are firing at a rate of 2,400 per minute. So the number of times we fired equals 2,400 bullets per minute divided by how many seconds per minute we have? 60 seconds per minute. Right? And every time we fire, we continue firing for 3 seconds. Yani we fire 3 seconds and then we stop. And then we fire 3 seconds and then we stop, and so on. So it's 3 seconds. When we hit every time the 3 seconds equals how many bullets we fire? It's 3 seconds multiplied by the rate of bullets per second. We don't have the rate of bullets per second. We have the rate of bullets per minute. So we change it into seconds. 2,400 bullets per minute divided by 60 seconds per minute, which gives us 40 bullets per second. So this gives us 40 bullets per second. Now, for 3 seconds, you keep firing for 3 seconds, then it's the number of bullets is 3 seconds multiplied by 40 bullets per second, which gives you 120 bullets. So in here, which is the number of times you fired, is 120. And the probability of hitting, which is A, is 0.4, did not change. And we are asked here to find the probability of having exactly 50 hits out of 120. واضح السؤال؟
واضح يا دكتور.
طيب. So the probability of 50 hits equals, as we did before, it's 0.4, which is the probability of hitting, to the power 50, because we hit 50 times. So we raise 0.4 to 50. Multiplied by 1 minus 0.4, which is the probability of missing, to the power 70, because 70 times out of 120 we missed. And we have 120 choose 50. Now, if you try to calculate this, 120 choose 50, this is equal 120 factorial divided by 50 factorial divided by 70 factorial. Now, for you, if you don't have a computer, if you would like to, if I give you this in the exam, or if you have it while you are trying to calculate it very quick, on the go, you are an engineer and you are trying to do some first dimensioning of certain problem. Then in this case, 120 factorial is prohibitively difficult to calculate, because you need to multiply 120 by 119 by 118 all the way down. So this is difficult to calculate, or at least takes time, unless you have a computer. And even if you have a computer, it's not something that the computer would love to calculate. And because of that, we have 2 approximations. For large N, when you have large N, we have 2 approximations to calculate the N choose R. Okay, let's talk about the first approximation. We have the Stirling's formula, which basically approximates M factorial using this formula, the green one, for large M. And it's a very good approximation. If you look at, if I zoom in, the Stirling formula versus the fractional where you calculate, you can see that they are almost exact match. Okay? And for large M, even the error is less than 1%. So it's a very nice approximation for m larger than 10. Now, using this Stirling's formula, the first approximation is de Moivre Laplace approximation, which gives you the approximation of the whole thing. N choose k, p to the power k, multiplied by 1 minus p to the power n minus k. The whole thing is approximated by this red equation. As you can see here, there is no factorial at all, and it's a simple exponential function. This works when n and k and n minus k are large. And k is close to n multiplied by p. So this works when you have n, k, and n minus k are large, and k is close to np. Okay? Now, so this is basically, these are the conditions that the Laplace approximation works. Now, if you have n is very large and p is very small, this fails. This approximation in the red equation fails. If n is very large and p is very small. In this case, we have the Poisson approximation, which is given by this equation. And this is for n large and p small. So we have two sets of two approximations. One works when nk and n minus k are large, and k is close to np. And the second, which is Poisson approximation, works when n is large and p is small. Okay? Let's have some, let's try to solve the same question now. Back to the torpedoes.
دكتور
تفضل.
في فورمولا شيت بالاكزام لا لازم احفظ
لا هذه الاشياء ما تحفظها.
تمام.
يعني مثلا الان خلينا نقول البرميتيشن والكومبينيشن هذه فاهم ما فيها حفظ. You need to understand how to calculate them. لكن equation مثل هذه الحمراء والهنا, these are not for remembering. These are not sorry for for remembering. هذه الاشياء لو احتجتها هنعطيك اياها. فما في formula sheet. If you need anything, it will be given to you. هذا اللي رد السؤال باختصار.
تمام.
So let's go back to the example here. So we said that n equals 120 and k equals 50. So np equals 120 multiplied by 0.4, which is 48. So you can see that we have n large, k large, and k is close to np. Okay? And because of that, they satisfy the Laplace approximation. And hence, we can use Laplace approximation. So the probability of 50 hits, which is 50 choose, so the 120 choose 50, and we'll continue with this. If we calculate it using the Laplace transform, approximation, it will be 0.0693. And if you do it yourself using n choose k approach, you will find that this is not very far. أي سؤال يا شباب؟ Any question? طيب, so let's have one example for about combined experiments. Okay. So we have a pair of dice rolled n times. We are interested in these questions. Find the probability that 7, so we are looking here at a pair of dice rolled n times, and every time we look at the sum of the two numbers coming out of the pair. So every time we repeat, we have two dice. We look at the sum of the two numbers at the two dice. Okay? And we are interested in finding the probability that 7 will never show up in n times. And the probability of obtaining double 6 at least once. And the number of throws required to assure more than 50% of success of obtaining, more than 50% success of obtaining double 6 at least once. So these are some questions. You can create your own. We'll solve one by one. Okay. So واضح السؤال؟
Yes.
طيب. So the first one is we have a pair of dice rolled n times. So the probability of 7 will not show up. First of all, before we look at the n times, we need to look at one time. What is the probability of 7? So if A equals 7, what is the event in which we get 7 as a sum of the two pairs? When you get 1, 6, 2, 5,
2,
3,
5,
4,
3, 4.
4, 3, 5, 2, 6, 1, right?
Right, doctor.
So the probability of A, which is 7, now we are talking about one experiment, not n times, one of them. In order to be able to solve this type of questions, you need to first of all ask yourself, for one of the experiments, what is the probability of this event? 7. So
6
what is the
over
probability of A? It's 6
over 12.
over, لا ليش 12? How many outcomes you have when you roll two dice? How many outcomes you have?
36.
36.
36, right? لو تتذكروا الإكزامبل اللي حطيناهم اللي كانت مثل الماتريكس. Go back to there. You will find it. Okay, so it's 6 times A is 6 occurrences out of 36. So the probability of A is 1 over 6. Which means that the probability of A doesn't happen, here no 7, is 5 over 6. Okay? So here we as if we are defining a Bernoulli trial. You have an experiment which is rolling a die, and we define the probability of A is having 7. So the event A is having 7, and A complement is having no 7. So any number, any sum, but not 7, which has a probability of 5 over 6. So the probability of 0 sevens, or let me, the probability of A occurs 0 times out of n equals what? Equals the probability of A complement to the power n, right? Because 0 times, it doesn't happen. Multiplied by the probability of A to the power 0. Multiplied by what? N choose 0. Right? Now this is 1, this is 1, and you end up with probability of A complement equals to the power n, which is 5 over 6 to the power n. This is the probability of having 7, never having 7, sorry, in n times. واضح شباب؟ Any questions? How did we do this? شباب شكله اليوم سهرانين أمس كنتم ما في interaction اليوم مثل دائما.
لا واضح يا دكتور.
طيب others any questions؟ طيب so let's go back to the second question. What is the probability of obtaining double six at least once? Now in order to do this, first of all we need to ask ourselves, when we roll the die once, not n times, once, what is the probability of obtaining double six? بعد كده نحلها ل n times. Yes. قبل ما هذا ارسلوا لي على البرايفت شات الله يخليكم. What is the probability of obtaining double six when we have only rolling one time? One time. So the question that you need, I need your answer on the private chat. What is the probability of obtaining double six if we roll the pair of dice only one time? Yes, I deleted the. Why do I repeat again? شباب, I'm not receiving anything. قليل اللي أرسلوا لي الآن. طيب, ممتاز. So the probability of having double six if we roll the pair of dice once is 1 over 36. Okay, it's basically the probability of having double six out of one, which is once, happens only once, out of 36 different events when we roll the two dice. So the probability of B here, which is double six, is 1 over 36, which makes the probability of B complement, اللي هو double six, doesn't happen when we roll once, it's 35 over 36. Okay? Now, the question that we are interested in, what is the probability of, the event that we are interested in is X, which is having double six at least once in n times. Okay? Double X is defined as double six at least once in n times. هذا الevent اللي you are interested in finding its probability. Now you can ask yourself, what is the probability of its complement? اللي هو double six will not show up in any of the trials. Double six, X is double six at least once. يعني if I roll 10 مرات يطلع لي double six at least once. معناها once, twice, 3 times, 4 times and so on. الكومبلمنت حق هذا الإكس is double six will never show up in any time. صح ولا لا؟
صحيح.
And the,
Yes.
and the probability of this complement of X equals the probability of no double six in the first time, which is B complement. يعني X happens if B complement happens in the first time, B complement happens in the second time. B complement معناها no double six in one time. B complements happen in the third time, and so on until the nth time. So the probability of X bar, which is the complement of X, equals the probability of B to the power n. Right? صح يا شباب ولا لا؟
Yes.
Which is
Yes.
35 divided by 36 to the power n. Which makes the probability of X, اللي هو اللي احنا interested in فيه, double six at least one times, it's equal to 1 minus the probability of X bar, which is 1 minus 35 divided by 36.
دكتور,
تفضل.
can I just say 1 over 36 to the power n?
لا. 1 over 36 to the power n equals the probability that you have double six only once. Only once. sorry, it's double 6, not only once. Double 6 n times. صح؟ لأنه هذه equal probability of b to the power n. This is equal to double 6 n times. هذا ما كان السؤال. السؤال كان at least once in n times. يعني at least once in n times means what؟ خلينا نقول n equal 10. وخلينا نقول n equal 5 بس عشان السهولة نعرف نعد. ايش يعني at least once in 5 times؟ معناها مرة ومرتين أو مرتين أو 3 مرات أو 4 مرات من 5 أو 5 مرات من 5. هذه اللي 1 over 36 to the power n is double 6 in 5 times اللي هي واحدة one event out of 5 events. واضح الفكرة؟
ايوه وضحت يا دكتور.
تمام؟ فأنت خلينا نقول you have two ways. You can calculate this as probability of x. خلينا نقولها بالطريقة هذه. You can calculate this as what we did is 1 minus probability of x complement, or you can calculate it as summation from I equal 1 to n, which is the probability of having double 6 ولا خلينا نكتب b probability of b I times. Okay, I times. نكتبها بطريقة شوية محترمة. b I times. تجمع السميشن from I من once إلى twice إلى third time up to n, which is equal to summation I equal 1 to n. The probability of I times is probability of b n choose I, probability of b n choose I, probability of b to the power I 1 minus probability of b to the power n minus I. هذه الطريقة الثانية اللي تحلها. اثنينهم يعطوك نفس الأنسر. واضح شباب؟
Yes.
1
Yes.
minus this 1 minus this هذا equal 1 minus the probability of b to the power b complement sorry to the power n. هذا equal to this equal to this لأنه في السميشن I equal 1 to n نحن if we sum from I equal to 0 to n we get 1. So what is missing here is when I equals 0 اللي هو هذا الترم. طيب ممتاز. أي سؤال ثاني before we go to the last point؟ طيب now the last question is another. تفضل.
If we can we predict the end? So if the question says you keep rolling a die until you hit 6, which n will probably the 6 will happen.
Oh, so basically you want here the n at which the double 6 happens.
Yes.
طيب هذه الآن تودينا السؤال الأخير. Let me look at this and then I will answer the question. You will find the answer here. So the last question is find the number of throws highly related to what you are asking to assure more than 50% success of obtaining double 6. إيش يعني؟ Find the number of throws required to make sure that we get 50% success of obtaining double 6. معناها we want the probability of x to be larger than or equal to 0.5. Right? Larger than or equal to 0.5. Larger than without equal. لأنه at least here. To assure more than. ما في more than or equal. So we would like to have the probability of x larger than 0.5. And because of that, in order to do this, we solve for this inequality. What is the probability of x? It was 1 minus 35 over 36 to the power n. If this is larger than 0.5, then we just simplify. This is less than 0.5, and we try to look to solve for n. هذا هو اللي نبغاه نحن. We want to solve for n. So solving for n, we get basically n larger than this number, which is larger than 24.6. So in order to assure 50% success, then the answer is you need at least 25 throws. مو 24 لأن the answer 24.6. You cannot throw 24.6 times. You have to go to the larger number لأنه في هنا inequality is larger than. So the answer is you need at least 25 throws. Okay? واضح يا شباب؟
Yes.
Yes.
تمام. طيب. أي سؤال ثاني؟ No questions? طيب, so basically you can see now in chapter 1, what we did in chapter 1 is we talk first of all about the set theory, and we did not do this just for fun because set theory told us how to deal with events, right? Because at the end, events are subsets of the sample space. And because of that, we needed the set theory to understand how to deal with the events. And the events at the end are subsets of the sample space. Then we talked about axioms of probability. And we defined 3 axioms. And we talked about how to calculate probability. We defined what we call experiment and the event, and how to calculate the probability of any event on a certain experiment. And we said that the axioms were that the probability is positive always, as well as 0 or positive, and less than 1. And the probability of S is 1, which is the certain event. The probability of phi is 0, which is the impossible event. And we talked about the probability of the union of mutually exclusive events, where basically it's equal to the summation of the individual probabilities. And then we talked about a total probability law, which basically deals with the probability of A being equal to summation of probability of A given BI, probability of BI, I equal 1 to n, where BI's here are mutually exclusive. And this give us the what we call Bayes rule. And before that, we talked about conditional and joint probabilities. And we said that conditional probabilities are the conditional event probability is related to the probability of an event A given that another event B happens. And we said that if in mutually exclusive events, the probability of event A given B equals 0, because if B happens, because they are mutually exclusive, there are no common factors between them, A cannot happen. And then we define what we call independent events. And we say that independent events are the opposite of mutually exclusive events. They are, if one happens, the other may or may not happen. So the probability of A given B equals the probability of A. The probability of A does not change whether B happens or not. And we gave several examples of that, and we ended up with the combined experiment and the counting principles. And we said that we are doing counting principles because they help us in finding and counting how many times an event happened in a combined experiment, which makes the finding the probability of that event easier. And this basically concluded chapter 1. أي سؤال يا شباب على اللي سويناه إلى الآن؟ Now in chapter 2, طبعا there's no time to go over anything in chapter 2, but we'll give you only introduction about it. Chapter 2 is about random variables. So we will define what we mean by random variables, a random variable. We'll talk about conditions of random variables and the types of random variables. We'll define two distribution functions, the probability density function and the cumulative density distribution function. We'll talk about different random variables, mainly the Gaussian random variable and other examples like binomial, Poisson, uniform, exponential, and so on. And we'll end up with what we call the conditional density and distribution functions. So the definition of random variable, we'll just introduce it to you so that I motivate the next class. Now, in many, as you will see as we go through the course, and as I mentioned before, in many cases, we are not really interested in the outcome itself of an experiment. We are interested in some numerical measurement of that outcome. Okay? So for example, when you have this head and tail, you might not be interested really in having head and tail per se. You are interested in basically allocating numbers. For example, losses and gains if you get head or tail. هذول الناس حقون المراهنات مثلا قمار. If you get head, for example, you assign it 0, تخسر. If you get tail, you assign it 1, تفوز مثلا. Okay? So in this case, we are not interested in really head or tail per se. We are interested in some numerical value that translate these outcomes. And because of that, the random variable comes into play here when we map the outcomes of an experiment into the real line. So instead of every time we look at the outcomes and we list them, no, we will work only with real numbers. It makes our life easier. It makes everything mathematically simpler to define and calculate without worrying about the experiment, the underlying experiment. So for example, you can ask yourself, for example, the probability خلينا نقول the distribution of scores in an exam عادة يطلع كأنه Gaussian random variable. طبعا احنا لسه ما اخذنا الاشياء هذه بس يعني trying to motivate the concept. So the outcomes of the exam or the scores of the exam at a large exam of large number of students, usually the curve اللي نسميه curve نحن or انتوا تسموه curve looks like a Gaussian curve اللي هو شكله كذا. So معظم الطلاب في النص around the average قلة high scores قلة low scores. Okay. Now this is the scores of the students in the exam. Exam 315. Now if you take exam another exam, Math 101, you will find that it might follow the same distribution. So the concept here, without worrying about which exam you take, whether the scores or not, maybe I'm talking about the density of I'm talking about the example, the experiment might be measuring the temperature, not the scores. And you might end up with the same distribution. So the random variable gives you a way to get away from the sample space itself, the elements inside it, and work with real numbers instead. By mapping the outcomes of the experiment into real numbers. Okay? That way, the random variable, so the experiment, instead of worrying about which outcomes and what are the outcomes, we will look at numbers and find the distribution of these numbers and so on. It makes our life much easier. Next time, inshallah, we'll continue with the details. شباب أي أسئلة before I leave? The class, I think, باقي له
Doctor, I want to ask about the office hours.
The office hours are at 2 on Monday, Tuesday and Wednesday. The days that we don't have classes. At 2
o'clock?
Yes. So feel free to contact me between 2 and 3 on Monday and Wednesday. طيب.
Okay.
طيب, I think I will stop here because there's no time to continue another concept. Class is over, Shabab. If you have any question, let me know. Shabab. Okay. يعطيكم العافية. السلام عليكم.